Welcome back to Mr. DuPage's classroom. This lesson is for my Algebra 2 class. It is section 3.5, the rational root theorem, day 2. The rational root theorem states that if a polynomial has any solution that can be written as a fraction or integer, it will be in the list of numbers. So my possible roots, it is plus or minus the factors of the constant terms, or the constant term, I should say, which is the last number over the factors of the leading coefficient. Now, when we actually factored in first quarter, we had already figured out how to do this. What we did is we found out what multiplies to 10. So 1 times 10 and 2 times 5. The number that's in front of x there is always 1. So everything in these current lists, when I just have a 1 out front, is just going to be 1 over 1. It's going to be a whole number. But I'm going to show you how it all works all at the same time here, okay? So let's make a list of all possible rational roots for this cubic polynomial in example 1. So x will equal, I'm going to take, don't circle these, I'm just going to show you something, 1 over 1. But the rational root theorem says it's got to be plus or minus. So it's also going to be negative 1 over 1. Okay? Then I'm going to take 2 over 1. Since it has to be plus or minus, they would also have negative 2 over 1. Then I'm going to use 5 over 1. And negative 5 over 1. And finally 10 over 1 and negative 10 over 1. I'll show you what we're going to do with those here in a little bit. Another way that we could write that, though, so it's not such a long list, we don't want to keep writing those over and over and over, would be x equals plus or minus 1 over 1, plus or minus 2 over 1, plus or minus 5 over 1, and plus or minus 10 over 1. I don't care which list you end up using, but you need to use one or the other lists. And yes, you always have to write these lists out. Another way you could also write this, though, because it's all over 1, it could be plus or minus 1, plus or minus 2, plus or minus 5, plus or minus 10, because it's over 1. If it was not over 1, which we'll get to at another time, then you would have to obviously have some fractions in there. Okay? So now what we're going to do is we're going to test the roots until you find what one works. What that means is a remainder of 0, and we're going to use synthetic division. Now, there's the way we've been doing synthetic division, we would take, the first thing in my list is this positive 1 over 1. That's the first thing I'm going to try to use. So I'll take 1, put it in the box. I'm going to use the coefficients from our example. So 1, negative 6, 3, and 10 from example 1 up above. I have my addition and my space. I'm going to drop the 1. I have 1 times 1, which is 1. Negative 6 plus 1 is negative 5. Negative 5 times 1 is negative 5. 3 minus 5 would be negative 2. Negative 2 times 1 is negative 2. 10 minus 2 would be 8. Now, that did not come out to 0, so we know it is not going to be positive 1. Okay? Now I'll go ahead and check negative 1. If I have negative 1, I'm going to use the same coefficients. 1, negative 6, 3, and 10. Those all came from our example 1 up here. Give myself some space, drop the 1. 1 times negative 1 is negative 1. Negative 6 plus negative 1 is negative 7. Negative 7 times negative 1 is positive 7. 3 plus 7 is 10. 10 times negative 1 is negative 10. 10 minus 10 would be 0. Now, that did give us 0. Our remainder is 0. So this did work. These are the numbers I'm going to use. Okay? But this is also a factor for our problem. Okay? If you remember how we found that negative 1, we had Well, right now, let's just do it this way. I have x equals negative 1. I want to set this equal to 0, so I'll add 1 to both sides. So x plus 1 would then equal 0. So x plus 1 is going to be one of my factors. I'm going to make a set of parentheses. I'm going to use the opposite sign from this. So x plus 1, okay? The other factor, excuse me, which we talked about last week, comes from here. So since I started out with x to the third, this is going to be x squared minus 7x plus 10. All of that's going to be equal to 0. That is how I factor using my synthetic. Now I would double check both sets of parentheses and factor it as well. However, I want to show you something first. It's called short track synthetic. As you can tell from our example B here, if I were to keep doing synthetic over and over and over, if I had to do maybe 3 or 4 different options before I got to my answer, it's going to get pretty long using our normal synthetic rules, right? Here's another new way you can use synthetic. Either keep doing synthetic the way we've been doing it on a separate sheet of paper, or I can just write my coefficients up top. This will take some mental math, so if you don't think you're good at mental math, don't use this. I'm going to put my first number inside. I'm going to drop my 1. Well, now 1 times 1 is 1. 1 minus 6 would be negative 5. Negative 5 times 1 is negative 5. Negative 5 plus 3 would be negative 2. Negative 2 times 1 is negative 2. Negative 2 plus 10 would be 8. That did not work. So I can go down one more line. Negative 1 I'm going to try. This is exactly what I did with the long synthetic. Again, if you don't think you can use this, don't. I dropped my negative 1. Or my positive 1, I'm sorry. Positive 1 times negative 1 is negative 1. Negative 1 minus 6 would be negative 7. This whole line isn't working. Negative 7 times negative 1 would be positive 7. Positive 7 plus 3 would be 10. 10 times negative 1 would be negative 10. Negative 10 plus 10 would be 0. So this did work, and remember, just exactly the same as what happened here, okay? So I could use either one of those two synthetic processes. If you're going to use the long synthetic, make sure that you have a separate sheet of paper. If you're going to use the short synthetic, you should have plenty of room to go ahead and use it. I'm not going to tell you which one to use. Just pick the one that you're most comfortable with. I would try short track synthetic for a while though. Okay? So now what I'm going to do is I'm going to check each set of parentheses. Can I factor either one? Well, x plus 1 I cannot factor. Okay? Here I have our normal factoring that we did in first quarter. I have 1 times 10 are my possibles, and 2 times 5. I'm looking for it to add to negative 7. Well, 1 and 10, there's no combination that could ever add to negative 7. But 2 and 5 there is. So I'm going to set up 2 sets of parentheses. Okay? My sign in the back is positive. My sign in the front is negative. So both my signs will be negative. The first blank is filled in with x. The second blank is filled in with a 2 and a 5, because negative 2 plus negative 5 would get me negative 7. Okay? Now that I have it factored, how do I solve? Well, I'll set each parenthesis equal to 0. So x plus 1 equals 0. X minus 2 equals 0. X minus 5 equals 0, okay? Subtract 1, x equals negative 1, add 2, x equals positive 2, add 5, x equals positive 5. There's one new step that I want to use here. All it is I'm going to go ahead and write my answers in from smallest to largest. So x equals negative 1, positive 2, positive 5. Negative 1 smaller than 2 and 5, so I wrote it from smallest to largest. That way I just have a single line answer. Yes, I understand this can be a little confusing. It's not going to be as crazy as what I just did up top. I just showed you a few different things, okay? So please just bear with me. Follow along on example number 2 here, okay? Again, I need to make a list of all possible rational roots. So I'm going to find out what multiplies to 8. That's 1 times 8 and 2 times 4. I'm going to make my list. All right. Remember that I have to have the positive and the negative. So I'm going to write 1 over 1. Okay. So plus or minus 1 over 1. I'm going to use the next largest, which is 2. So plus or minus 2 over 1. Then 4 is my next largest. So plus or minus 4 over 1. And then plus or minus 8 over 1. Realize that everything over 1 is just a whole number. So I do not have to use that fraction right now. Okay. Now I'm going to test my roots until I find the one that works. The one that works is when I use synthetic division. It is the division that comes out as 0 in my remainder. Okay? So I'm going to start with positive 1. My coefficients are 1, 1, negative 10, and 8. I'm going to use short track here. If you do not like short track, what I would do is go ahead and do the synthetic on your own, see which one works out. But give short track a try here. Just follow along with short track as best as you can. I'm going to drop this one down. Now I have 1 times 1 is 1. 1 plus 1 would be 2. 2 times 1 is 2. 2 plus 2 minus 10 would be negative 8. Negative 8 times 1 would be negative 8. Negative 8 plus 8 would get me 0. So 1, 2, and negative 8 will work. I'm going to go ahead and write down my answer now. Remember that I'm going to have one set of parentheses that uses the opposite of this number. So x minus 1. The next set of parentheses will use my answer to my synthetic. So because it started as x to the third, I have x squared plus 2x minus 8. That is the factored form, okay, so far. Now I'm going to write both those down here. I'm going to factor and solve. So it'd be x minus 1, x squared plus 2x minus 8 equals 0. Well, x minus 1 I know I cannot factor. I'll bring that down. I'm going to find the factors of 8. 1 times 8, 2 times 4. I'm looking for something that can add to positive 2. Well, 1 and 8, there's no way that 1 and 8 can get me to positive 2. But 2 and 4 could possibly get there, and especially considering I have a negative, right? So set up 2 sets of parentheses. If my sign in the back is negative, 1 will be positive, 1 would be negative. I want to make sure that I have a positive 2. So would the 4 or the 2 end up being positive? It's going to be the 4. The 2 would be negative. I have x squared, so x goes in the first blank. I am fully factored now. So I'll take x minus 1 equals 0, x plus 4 equals 0, and x minus 2 equals 0. Add 1, x equals positive 1. Subtract 4, x equals negative 4. Add 2, x equals positive 2. Remember on the first example I told you I'm going to write my answers from smallest to largest. So my smallest number is negative 4. My next is 1. And my largest is 2. There is my answer. Okay? Let's go ahead and move on to number 3. Number 3, again, I need to make a list of all possible rational roots. So what multiplies to 3? 1 times 3. This will be a shorter list. Okay? So x will equal plus or minus, I'm going to use 1 first, over 1. Then I have plus or minus 3 over 1. Those are all my possible rational roots. Again, I'm going to use short track synthetic. If you still don't feel comfortable with it, go ahead and move on to long synthetic. But I promise you, you're going to want to figure out short track. Okay? My coefficients are 1, negative 3, negative 1, and positive 3. So 1, negative 3, negative 1, positive 3. My first choice is going to be positive 1. I'm going to try. So I bring that down here. I'm going to drop this 1. 1 times 1 is 1. 1 minus 3 is negative 2. Negative 2 times 1 is negative 2. Negative 2 plus negative 1 would be negative 3. Negative 3 times 1 is negative 3. Negative 3 plus 3 is 0. That is my remainder. So 1, negative 2, and negative 3 do work for me. Remember, my first set of parentheses will be this, the opposite of this number, so x minus 1. My second set of parentheses comes from here. So it will be x squared minus 2x minus 3. Okay? Again, in part C, I need to factor and solve. So I'll have x minus 1 times x squared minus 2x minus 3 is equal to 0. Find the factors of 3. 1 times 3. Could those possibly add to negative 2? Yes, they can. I can't factor x minus 1. Set up 2 sets of parentheses. My sign in the back is negative, so one sign's positive, one sign's negative. I want it to be a negative 2, so my larger will get the negative, my smaller would get the positive. X goes in the front. I'm fully factored again, so I'll have x minus 1 equals 0, x plus 1 equals 0, and x minus 3 equals 0. Add the 1, x equals 1, subtract the 1, x equals negative 1, add the 3, x equals 3. Again, I want to write this in smallest to largest, so x equals negative 1's my smallest, 1's my next largest, and 3 is my largest. Okay? On to the final problem. On to the final problem. Here I have the same situation. I want to make my list. So I'll have 1 times 4, 2 times 2. Okay? I want you to notice something here when I make my list. X equals plus or minus 1 over 1, plus or minus 2 over 1, plus or minus 2 over 1. Now, I have plus or minus 2 over 1 twice. What you need, or what you can do here, just get rid of the second plus or minus 2 over 1. We won't need it. And then finally, plus or minus 4 over 1. So I really only have 6 choices. Okay? I'm going to use short track synthetic again. So my coefficients are 1, 1, negative 4, negative 4. So 1, 1, negative 4, negative 4. I'm going to use positive 1 first. Drop my 1. 1 times 1 is 1. 1 plus 1 is 2. 2 times 1 is 2. 2 minus 4 is negative 2. Negative 2 times 1 is negative 2. Negative 2 negative 2 times 1 is negative 2. Negative 2 minus 4 is negative 6. So this row will not work. Positive 1 does not work. So I need to move on to the second choice, which would be negative 1. Again, drop your 1. 1 times 1 is negative 1. Negative 1 plus 1 is 0. 0 times negative 1 is 0. 0 plus negative 4 is negative 4. Negative 4 times negative 1 is positive 4. 4 minus 4 will be 0. So 1, 0, negative 4 will work because I had a remainder of 0. Again, remember my first set of parentheses will be x and the opposite of this, so it'll be x plus 1. My second set of parentheses comes from here. Since I started with the third power, this is going to be x squared. My x would be 0, so I don't need to write it. Minus 4. Okay? Now for part C, I need to factor and solve. So I bring down my x plus 1 times x squared minus 4. All that's equal to 0. Now, can I factor x plus 1? No, I can't. Can I factor x squared minus 4? This is some review. It is the difference of two squares, so yes, I can. Two sets of parentheses. The square root of x squared is x. The square root of 4 is 2. I have a positive sign and a negative sign. All that's equal to 0. Okay? Now that I'm fully factored, my next step is to set everything equal to 0. If I subtract 1 from both sides, I get x equals negative 1. Subtract 2, x equals negative 2. Add 2, x equals positive 2. Smallest to largest, so x would equal negative 2, negative 1, positive 2. And I am done. So that is the end of our lesson. What we did here is we found a possible list of factors for our polynomial. We used synthetic division to test them to find out which one of those factors will work for us. Once we found which factor worked for us, we set them equal to 0, continued to factor, and then solved. If you have any problems with this, guys, you really need to come in before school to get some extra help on this. If you're still struggling with factoring, please come in before school to get some help on this. If you're still struggling with the difference of two squares, please come in before school to get some help on this. We do not have time in class, even though there's a lot of extra time, we do not have time in class to go back through all of factoring. I can probably fix you in 10 minutes if you just come in either before or after school to get some additional help. All right? But thank you very much for watching this video. If you have any questions, make sure you bring them with you tomorrow, and have a great day.